Greetings, ladies and gentlemen. So, this particular video is going to focus on the very first exploration that we're going to talk about for mapping motion. So, what we're going to talk about today is kind of the pre-lab for what we're going to do on Thursday, which is we're going to do our first exploration into actually mapping out the motion of an object. In this case, we're going to start with just a simple little mechanical buggy. Now, the reason we have to start with this is because in the future, we're going to know enough that we can kind of cause a lot of interesting things to happen in physics. We can cause things to, change their motion. We can crash them. We can drop them. We can throw them against a wall. We can make them oscillate. But before we can do any of that, we have to be able to just talk about and map out how things move so we can understand how we can change it. All right? Now, for your notes today, you need to open up, go on Canvas. You need to open up what says Mapping Motion, the CVM Buggy Lab. All right, it's going to be week 2. You should see it. It's going to say, that. It should open up a Google Doc. What you're going to do is just kind of go to File, make a copy, and that's going to be what you're going to submit when we do our lab on Thursday or Wednesday, because I know this is for the block days. So, what we're going to do is we are going to utilize the fundamental features of this class for this first demonstration. And what I mean by that is that you're going to make some observations. Now, what I'm going to do is I am going to start this card. And what I'm going to do is I'm going to say the word start and I'm going to say the word stop. And in between start and stop, I want you to make some observations. All right, and you'll notice there's some space on your note sheet for you to write stuff down. Of course, you do not have to put your notes on the sheet if you do not want to. You are welcome to put them. If you want to make your own Google Doc, you're going to write them down on a piece of paper, whatever you're most comfortable with. It's up to you. All right? Now, remember, with observations, that's just using our 5 senses. In this case, because we're watching a video, really the only way you can do it is you can see things and you can hear things. All right? So I'm going to start this car. I'm going to let it start moving. You are only making observations between when I say start and when I say stop. Start. Stop. All right? I know that's pretty wild. It's going a little fast, maybe hard to see, so we're going to do it one more time. So once again, we're making observations. It's going to be about the cart, it's going to be about its motion, but we're just observing what is going on between when I say start and when I say stop. Start. Stop. All right. Now, customarily what I would say is, just pause the video, write some of these observations down, and then, unpause it, which you're welcome to do that if you want some time to process. But what we hopefully saw there are several things that are going on with the card. So some observations can be based on the card itself. It's red, it's lighting up, it's got the lights are on, the wheels are moving, and those observations can be really useful if we're trying to determine what's going on. So things like that, like the lights are on, the wheels are moving, I can hear this whirring noise. That tells me that something should be happening. So that's a good observation just to kind of make sure that we know something should be occurring. Now, on the motion front, we might have a slightly different observation. All right, there are a couple things you might notice about just kind of observing this motion. You might notice that it's moving forward. You might notice that it's moving kind of in a straight line. And then you also might notice, if you're kind of looking at it, that it's moving. And this is a very important observation for us to make. It's moving at what appears to be a constant speed, or kind of just a consistent rate. Okay? Now, this is where physics goes from just watching things to actually becoming a physicist. Because what we're going to do is we're not going to just use as observations. In order to make sure that what is actually happening is happening, we have to take what we observe and we have to actually prove it. So our first observation is we kind of observe this is moving at a constant speed. All right. What we're going to need to do is we're going to need to prove that's what this is doing. So right there, we actually have and the way we're going to do that is we're going to do a lab. So we actually have just answered another question. We have the purpose for our lab. What we're going to do in the purpose of this lab is that we are going to prove that this buggy right here, or the buggy you're going to have a video of, is moving at a constant speed. All right? And one other thing we're actually going to prove, and we haven't talked about how we're going to do that yet, but we might see as we go through the lab what might show that. We're also going to figure out how fast is this thing actually moving. All right? So, in order to do that, we need to talk a little bit about data. Because in order to run any sort of experiment, to make any sort of observation and kind of see if it's actually what we observe, we have to collect some data so we can look at it. Now, that raises the question, well, what can we measure about the cart? And that's a very broad question, and there's actually a lot of things we could measure. So we're going to kind of start with just some of the stuff and then narrow it down. So some of the things we can measure about the cart. The cart itself, we could maybe measure how much it weighs. Another way, we can also measure its mass. We can measure maybe the dimensions of it. But in terms of its motion, those measurements aren't going to be very useful. So we want to think about more, what can we literally measure using maybe things we have in the classroom. And of course, I know you haven't had a chance to come to the classroom. So we have to think about some of the features we have here. We have stopwatches, we have meter sticks, we have scales. What are some things we can measure with those pieces of equipment? Right? Well, off the top of my head, if I'm thinking about I have a stopwatch, then the first thing that comes to mind is, well, I guess I could measure the time it takes to move from one point to another. All right? Because what I could easily do is I could just have this thing moving across the table, and then I could just time it and record how long it took to do that using the stopwatch. So right there on your note sheet, it asks, what are some things we can measure in this lab? Well, one thing we can measure is the time it takes to travel. Now, what we're going to do is we're going to need to also record what we're using to do that, and it's pretty simple. We're just going to say time it takes to travel, stopwatch. That way we know not only what we are recording, but how we're going to record. Now, the other thing we need to record, or we can record, is knowing how long it took is useful, but we also might need to know the distance, how far it's gone as well. Because that's probably something useful. I mean, I want to figure out maybe how far did I go when I'm traveling. It's going to be pretty important for us. So, again, I can use something in the classroom. In this case, instead of using timer or stopwatch, I'm going to use the meter stick. All right? And what I can do is using a meter stick, I can measure the distance traveled, or I can measure its position, as we're going to talk about and kind of figure out what the difference between those two are on Wednesday or Thursday whenever you're in class. All right? But what that means is that gives us another piece of information that we can record. We can measure the time it's traveling and the distance it travels. All right? Now, the catch is we have to use those pieces of data to prove what we want to prove, which in this case is going at constant speed. So, in order to do that, we're going to have to think about how we can kind of tie all these things together. And to do that, we're going to think about the following question. Imagine this cart actually was leaking oil. And let's say every second an oil drop falls where the car is. All right? Now, that means that as it's moving every second, it goes drip, 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 and it basically maps out where it is every second. Now, if this is truly moving at a constant speed, we should probably notice something about this oil pattern. All right? And if we think about it, if it's going at a constant speed, we know that it's probably covering the same amount of distance every second, which means if we look at the oil pattern, we should see that the dots are the same distance apart. Or another way we can say it is that its position is increasing by the same amount every second. All right? Now, what that means is that now not only do we have a purpose for our lab, based off some observations we've made, we now have some items that we can measure, and we now have a method that we're going to use to record those things. All right? So, right there, that's kind of the description of our first demonstration of the year. Talking a little bit about how we can map the motion of this cart. What we're going to do now is we're going to take what we discussed, what we observed, and we're going to actually apply it in our lab setting, and we're going to decide if the carts really are moving at a constant speed or not. Okay? So, with that being said, that kind of covers the notes for this class period, covers the notes for the beginning of the pre-lab. So, I will talk to you all later. Have a great rest of the day.